Welcome to this comprehensive tutorial on constructors and destructors in C#, essential concepts for any aspiring developer. We'll explore how these fundamental building blocks of object-oriented programming help manage object creation and resource cleanup, ensuring your applications are robust and efficient. Constructors are special methods within a class, automatically invoked when an object is created. Their primary role is to ensure that an object's initial state is valid and ready for use, preventing uninitialized or inconsistent data. This automatic invocation simplifies object setup and reduces potential errors. They share the exact same name as their class and, crucially, do not have a return type, not even void, distinguishing them fundamentally from regular methods. This unique syntax is a key identifier for constructors in C#. If you don't explicitly define any constructors for your class, the C# compiler automatically provides a default, parameterless constructor. This compiler-generated constructor initializes numeric fields to 0, booleans to false, and all reference types, such as strings and other objects, to null, providing a basic, safe starting point for your objects. Parameterized constructors accept one or more arguments, allowing you to provide initial values for an object's fields directly upon creation. This is incredibly useful for instantiating objects with specific, meaningful data right from the start, rather than setting properties individually after creation. This flexibility enables objects to be instantiated with specific data, making your code more robust and adaptable. For example, you can create a car object and immediately define its color and model using a parameterized constructor, ensuring it's fully configured from the moment it exists. Copy constructors create a new object by replicating values from an existing object of the same class. This is particularly useful for performing a deep copy, where not just the references, but the actual values of complex objects are duplicated, preventing unintended side effects when modifying the copied object. Private constructors prevent external instantiation of a class, meaning you cannot create an object of that class directly using the new keyword from outside the class itself. They are often used in utility classes that contain only static members, ensuring controlled access and preventing the creation of unnecessary instances. Static constructors are used to initialize static members of a class. They are called only once, specifically when the first static member is referenced or the first instance of the class is created, whichever comes first. A key characteristic is that they are always parameterless and cannot have access modifiers. Constructors can have various access modifiers like public, private, or protected, controlling where they can be called from. Furthermore, a class can have multiple constructors through a concept known as constructor overloading, where each constructor has a different signature, meaning a different set of parameters. The new keyword is fundamental for creating class instances in C#. When you use new followed by a class name and parentheses, it triggers the appropriate constructor based on the arguments provided, allocating memory for the new object and performing its initial setup. In a class hierarchy, where one class inherits from another, constructors are called in a specific and predictable order. The base class constructor is always executed first, followed by the derived class constructor, ensuring that the foundational components of an object are initialized before its more specialized parts. Constructors can also throw exceptions if an object cannot be initialized correctly due to invalid input or other issues. This provides a robust mechanism for error handling, preventing the creation of invalid objects and ensuring data integrity from the outset. Now, let's shift our focus to destructors, also known as finalizers, which are crucial for managing unmanaged resources. While constructors handle object creation, destructors are concerned with the proper cleanup of resources when an object is no longer needed. Destructors are special methods automatically called by the garbage collector when an object is no longer needed and its memory is being reclaimed. This process is part of C#'s automatic memory management, but destructors provide a hook for specific cleanup tasks that the garbage collector doesn't handle directly. They are primarily used to release unmanaged resources, which are resources not directly managed by the .NET runtime. Examples include closing file handles, terminating network connections, releasing database connections, or freeing memory allocated outside the managed heap. This ensures that external resources are properly returned to the operating system. Destructors are uniquely identified by being prefixed with a tilde, followed by the class name. They cannot have access modifiers, parameters, or return types, and a class can only have one destructor. This strict syntax ensures their specific role in resource cleanup. You cannot call destructors directly from your code. Their execution is implicitly managed by the garbage collector, making their timing unpredictable. The garbage collector determines when an object is no longer reachable and thus eligible for finalization, which can happen at any point after the object is no longer referenced. It's important to remember that destructors are not from managed resources, as the garbage collector handles those automatically. Attempting to use a destructor for managed objects is redundant and can even introduce performance overhead without providing any benefit. Destructors cannot be defined in structs, only in classes. Internally, a destructor is implemented by the C# compiler as an override of the finalized method on the base system, object class. This is how the garbage collector hooks into the cleanup process. Now, let's explore how these concepts apply within the Unity 3D engine, starting with constructors. Unity has its own lifecycle management, which interacts differently with standard C# object creation patterns. In Unity, constructors cannot be used in classes that inherit from monobehavior because these components are not instantiated directly using the new keyword. Instead, they are added to game objects using the addComponent method, which Unity handles internally. Instead of constructors, awake and start methods are typically used for initialization and monobehavior components. These methods are part of Unity's lifecycle callbacks and provide predictable points for setting up your scripts and game objects. Awake is called when the script instance is being loaded, even if the script is disabled, making it ideal for setting up references between scripts. Start is called just before the first frame update, only if the script instance is enabled, making it suitable for game logic that depends on other components being fully initialized. For cleanup in Unity, the onDestroy method is generally preferred over traditional C# destructors. This method is specifically designed to integrate with Unity's object lifecycle and provides a reliable point for resource release. onDestroy is called at a predictable time when a game object is being destroyed, either manually or when a scene unloads. This makes it ideal for managing resources in a game environment, such as unsubscribing from events, releasing pooled objects, or saving data associated with the object. C#'s traditional destructor is considered less useful in Unity because its execution is not tied to Unity's lifecycle. This leads to unpredictable cleanup, which can cause issues like memory leaks or unexpected behavior if resources are not released at the correct time within the game's flow. When designing your classes, a crucial best practice is to keep constructors simple, focusing primarily on initializing members and avoiding complex or time-consuming operations. Heavy logic should be placed in separate methods, ensuring that object creation is fast and efficient. Consider throwing exceptions from constructors if the object cannot be initialized correctly due to invalid parameters or other critical issues. This ensures that you never end up with a partially or incorrectly initialized object, thereby maintaining data integrity and preventing runtime errors later on. Adding a parameterized constructor to a class that previously only relied on the compiler-provided default parameterless constructor will remove that default constructor. This can cause breaking changes in existing code that attempts to instantiate the class without arguments, so careful consideration and refactoring are necessary. For unmanaged resources, the recommended approach is to use the dispose pattern, often implemented with the iDisposable interface. This pattern allows for explicit, deterministic resource release. A finalizer or destructor can then be used as a backup, guaranteeing resource release even if dispose isn't explicitly called by the consumer of your object. Understanding constructors and destructors is fundamental for writing efficient, robust, and maintainable C# code, whether you're developing console applications, desktop software, or engaging in game development with Unity. Mastering these concepts empowers you to control object lifecycle and resource management effectively.